Hello students, in this video we'll discuss about syntax directed definitions and types of attributes. First of all, what we have completed and where we are. See, as part of our first unit we have discussed about the lexical analysis, then we have done with the syntax analysis. So in the last videos we have discussed the top down parsers and bottom up parsers. This we have done, and the output of syntax analysis will be given as input to the semantic analysis. So currently we are discussing about semantic analysis phase. So what is the main aim of semantic analysis? Syntax analysis check whether it is syntactically correct or not. So if the statement is syntactically correct, then that will be given as input to the semantic analysis. So this will check whether it is meaningful or not, whether the statement is legal statement or illegal, even though it is syntactically correct. Then first, what is the main aim of the semantic analysis? So it will verify whether it is semantically correct or not. That's what I told you, right? So we can say that meaningful or not. Then it is going to catch the errors which are not caught in the previous phases. See, in the first phase of the compiler, we'll check only the lexical errors, like whether it is not satisfying the identical rules or not, like that invalid identifiers. If it is starts with underscore or a letter, that is a valid identifier. If it is starts with a number, like if you declare int a, so this is a lexical error, will be caught by the lexical analysis. And when it comes to syntax analysis, for example, if you have written a statement like this, int a comma b semicolon, if the semicolon is missing, it is not a lexical error, but that will be caught in the syntax analysis phase. Now for example, if you have given a statement like this, c equivalent to a plus b, so this statement is syntactically correct, and if you write int a, syntactically correct. If you write bool b, syntactically correct. If you write double c, syntactically correct. So all these four statements are syntactically correct, but together this is meaningless statement in the Java language. Why? Because implicit conversion of two different categories is not possible in the Java. So even though every statement is syntactically correct, but that statement is meaningless statement, such kind of errors will be detected at the time of semantic analysis phase. So let me give you one more example. If I take like this, a plus plus, right? When it comes to C language or Java, a plus plus is syntactically correct. And if I write int a equivalent to 10, see guys, the two statements are syntactically correct and semantically also correct. But when you have taken like this, a plus plus, then if I write here double a equivalent to 10.0, then this statement is syntactically correct, this statement is also syntactically correct, but together this statement is meaningless statement. Why? We cannot perform increment or decrement or operators on non-integral data types. Such kind of errors will be identified at semantic analysis. Not only that, see, if they have used before they have declared, or if the right types, just now we have discussed increment or decrement are having the right types or not. See whether they are instantiated before they are using, or whether they are inverted, where the classes, base classes are not existent. Such kind of errors will be detected. So after semantic analysis, we can say that the program is legal statement or legal program. See, these syntax directed definitions are also called as attributed grammars. Means the predefined thing in semantic analysis. See, in lexical analysis, the predefined is regular expressions. So we are going to specify the rules of lexical analysis with the regular expressions, and in syntax analysis, the predefined is context-free grammars. When it comes to semantic analysis, how to verify whether it is meaningless or not? By using the SDTs or SDDs, syntax directed translations or syntax directed definitions. What does it mean? So simply SDTs, right, or SDD is nothing but context free grammar plus action rules. So every production in the grammar is going to have at least, right, is going to have 0 or 1 or any number of action rules. So these action rules will be evaluated at the time of execution. I mean to say that, so at the time of semantic analysis. And these SDTs are also called as attribute grammars. Means every non-terminal or terminal is going to have some attributes. So they are going to describe the symbol. Either it can be a type, value, right, address, location, scope, can be anything. So attributes are the description about the symbol. And when they are going to evaluate these attributes or action rules, so by using the depth first traverser. So we'll discuss this later. So once the traverser is completed, all the attributes are going to be evaluated and that will be translated in the form of input. And let me take some example of attribute grammar. See, this is the production and these are the action rules. We can also call it as semantic rules. And after that, whatever we are having here, that is called an attribute. So sometimes a non-terminal may have one attribute, zero attribute, two attributes, three attributes, can be any. So here we are defining value, lex value, or even we can take the e dot type, or we can take e dot location, or we can take e dot scope, or we can take whatever it is, right? So they are just the description about the symbols, right? So it can be numbers, strings, memory locations, indexes, data type, scoping information, intimate representation, whatever I just discussed that I mentioned here. Now, hey guys, semantic analysis means going to verify whether the statement is meaningful or not. So with the help of actions. Now, of course, in this example, we are not going to discuss much about the type checking or meaningful. So if an action rule is given and if the input is given, how these action rules are going to be evaluated, right, in this input string that we'll discuss, right? So to evaluate the action rules, we should follow some methods like SDT evaluation. We have so many. So later in this unit we'll discuss. But before that, if you are given an input and the SDT, how you have to evaluate in a simple way that I'll tell you. So step 1, you have to take the input string. That's what we have taken. Step 2, we have to draw the parse tree. If parse tree is constructed, then only we can say that it is syntactically correct. Step 3, go for the dependency graph. So once you got the dependency graph, then go for the evaluation. Right? Or before that, you can specify the evaluation order. Once you got the evaluation order, then you can execute the action rules. Execute the actions. So this is how we are going to do it. So only 5 steps. Let me go with this. 9 plus 5 plus 2 n. So there's a string. First construct the parse tree. So you can find the parse tree here. Once the parse tree is constructed, then you have to draw the dependency graph. So as they have mentioned, depth first traverser. Then you have to come from here. So always the parent is depending on what? Children. According to the depth first. First you have to evaluate the children before evaluation of parent. So let me go with this. So the parent is depending on children, right? Then the E is depending on E and T and plus, right? We can say that all the parents are depending on children. So then if you want, you don't need to mention everything here. So let me just go with this. L is depending on E and N, E is depending on E plus T, like that. So let me write. So first one which is going to be evaluated is F tends to 9. This is the first one to be evaluated. Why means E is depending on E plus T, E is depending on T, T is depending on F, F is depending on 9, but 9 is depending on nothing. So F is depending on 9, but 9 is depending on nothing, so I can evaluate this. So after first F is evaluated. Once F is evaluated, then I can evaluate the T. This is the second one. Once T is evaluated, then I can evaluate the E. So this is the third one. Once E is evaluated, I cannot evaluate this E. Why? Because E is depending on T, T is depending on F is depending on phi. Phi is not depending on anything. So the next one to be evaluated is this fourth one, and the next one this. Now I got all. So E is evaluated, plus is not depending on T. Then you can evaluate this sixth one. So then after that you have to evaluate, you cannot evaluate this, E is depending on T, T is depending on F. So next one to be this seventh one, then T tends to F, eighth one, then the ninth one, right? So finally you have to evaluate this 10th. Then how you are going to get it, right? Let me go with this, guys. See, now first one, F tends to 9. What is the action rule? F dot value equivalent to digit dot value. So I can say that F dot value is 9. Then T tends to F. Next one, T. So T tends to F means T dot value equivalent to F dot value. Then you can write here 9. Then same way, E dot value equivalent to T dot value. Then what is the fourth one? We have to evaluate F tends to 5. Same. F dot value equivalent to digit dot lex value. Then you can say that F dot value equivalent to 5. So same way, T dot value equivalent to 5. Now you can evaluate this. What is the sixth one? E. E means E tends to E plus T. What is the action rule? E tends to E plus T. E dot value equivalent to E dot value plus T dot value. Means 9 plus 5 is nothing but 14. So same way, F tends to 9, you can write 2 here. Then you can write 2 here. Same, E tends to E plus T. What is the action rule for E tends to E plus T? E dot value equivalent to E dot value. Then you can write 16 here. And finally, L tends to En, print E dot value. 16 will be printed. So this is how it is going to be done. So same thing we have discussed here. First, the dependency graph, how we have done. So whatever I've discussed earlier, that I've mentioned here, right? But I didn't use the existed one. I just wrote everything in front of you, right? And there are attributes. These attributes, whatever we have used value, they are categorized into mainly two types. One is synthesized attribute and another one is inherited attribute. Let's see here. See, this value is evaluated from E dot value and T dot value. Means parent value is evaluated from the children. Means if you take this production, E tends to E plus T. Now this E dot value, parent dot value equivalent to child dot value plus child dot value. So if the parent value is evaluated in terms of the children, then we can call such attributes are synthesized attributes, right? Synthesized means if parent value is evaluated from the children, we can call it as synthesized. But for example, if you take this action, guys, D tends to TL. So D tends to TL. Now when you are executing this action rule, we can write L dot in equivalent to T dot type. Means L dot in equivalent to T dot type. So this L value is depending on its sibling, not on children, right? So if an attribute value is evaluated from its sibling or from the parent, then we can call it as inherited attributes. According to the Java, what is inheritance? Deriving the properties from parent. Same way, if the value is evaluated either from the sibling or from the parent, we can say that it is inherited. If the value is evaluated from the children, then we can call it as synthesized. Synthesized means children. Inherited means sibling or parent. So in this case, T dot type equivalent to int. We are getting it from the child. T tends to int. So T dot type equivalent to from child we are getting. So that's why it is synthesized. But L dot type equivalent to T dot type means from the sibling. L is deriving from its sibling. That's why it is inherited attribute. We'll discuss more about this. So in the next video, we'll discuss about all those types and evaluations. So that is evaluation of SDD and some sub classes.